So in this video, we'll be looking some more at the quadratic formula, and in particular, a part of the quadratic formula called the discriminant. Now, just to kind of review what the quadratic formula is for, is that if somebody gives us a formula, an equation that looks like ax squared plus bx plus c is equal to 0, where a, b, and c are just numbers, then the graph of that equation is going to be a parabola, and what the quadratic formula is giving us are the x-intercepts, or the roots to that particular equation. Now, where is the discriminant actually popping up? Well, the discriminant is really calculated in terms of those numbers a, b, and c. And in particular, the discriminant, and we'll call the discriminant capital D is going to be equal to b squared minus 4ac. So exactly what that tells us is the number of roots that the quadratic is really going to have. So how many times are we going to cross the x-axis? And so in particular, if d is going to be positive, then we have two x-intercepts, two roots. If d is equal to 0, then we only have one root, and if d is negative, then we have no real roots. And so again, we're talking only particular real roots. If you want to start talking about complex numbers, then that's a slightly different ballgame, and we'll come to that maybe a little bit later on. But for now, we're just talking about the real numbers, and so that's what the discriminant is really going to tell us. Now, that really gives us kind of three pictures, or three types of pictures that we can have. The first one, whenever we have two real solutions, so when our discriminant is positive, we get a picture that looks something like this, and we see our parabola crossing the x-axis twice. When d is equal to 0, we only have one real solution, and so kind of we think of that parabola as sitting really on the x-axis. So it just comes down to the x-axis, it touches it in one spot, and then it goes back. And then the case when our discriminant is going to be negative, we have no real solutions. And so that's going to be the case whenever our parabola is going to open away from the x-axis, and it's going to be above the x-axis. So if everything is contained, so if the whole thing is just above the x-axis, we never cross, and so our discriminant is going to be negative at that point. So let's look at an example. Suppose we're asked to compute the discriminant for the equation x squared minus 5x plus 6 is equal to 0. Well, kind of the first thing that we're going to do, we kind of go back to our form for our quadratic, which is looking like ax squared plus bx plus c is equal to 0, and we have to figure out exactly what are a, b, and c. And so a is going to be this number that's multiplying our x squared. Now, if we don't have a number written there, we're assuming that that number is going to be 1. So we've got a being 1. B is going to be negative 5. So anytime that we've got a subtraction sign in there, that really means that we've got a negative coefficient. And so our B is not 5, our B is going to be negative 5 in that case. And for C, well, C is just going to be this number on the end that doesn't have any x on it. And so in this particular case, C is going to be 6. So we've got the numbers A is 1, B is negative 5, and C is going to be 6. So if we come down and compute the discriminant, we've got capital D is equal to b squared minus 4ac. So if we plug in the values that we've got, then b is negative 5. So we've got negative 5 squared minus 4 times a is going to be 1 and c is going to be 6. Well, negative 5 times negative 5 is going to give us 25. 4 times 1 times 6 is going to give us 24, and 25 minus 24 is going to give us 1. Since that's positive, that tells us that we have 2 real roots. Now, we can actually get this we can confirm this or check it by actually taking this equation or something we get from it, a function from that, and plugging it into GeoGebra. And so what do we actually put into GeoGebra? Well, we imagine just taking the 0 and replacing it with the variable y. So that we're going to plug in y is equal to x squared minus 5x plus 6. All right, so let's bring up GeoGebra and see exactly how we might do that. And so if we go in, and we can pretty much put in the equation exactly as we see it. So we've got our y equal to, so this is down in the input bar, y is equal to x squared. And in order to do the x squared, we put in the square with the symbol caret. So this symbol up above the number 6 on the keyboard. So if we do shift 6, that will give us the caret, and then we put in the 2 for the exponent. So x squared minus 5x plus 6, and then we hit enter, and that gives us a picture that's looking something like this. And we can see that sure enough, it does look like we're going to cross the x-axis. We do cross the x-axis in 2 spots. So we've got one right here at 2, and we've got another one right there at 3. And so sure enough, our discriminant was correct. We have 2 real roots to that equation. Now, let's look at another example where we have, we want to compute the discriminant for 4x squared plus 12x plus 9 is going to be equal to 0. So again, one more time, we are determining what exactly are a, b, and c. So a is going to be the number in front of the squared term. So a is going to be 4. B is going to be the number that's just multiplying plain old x. So b is going to be 12 in this case. And c is going to be the number that doesn't have a variable on it. So c is going to be 9. So we've got our a, b, and c as being 4, 12, and 9. So we can come down and compute the discriminant for that one. Our discriminant again being b squared minus 4ac. So we've got b as being 12 minus 4 times a is going to be 4, and c is going to be 9. So 12 squared, so 12 times 12 is going to give us 144, minus 4 times 9 is going to give us also 144. So 144 minus 144 gives us a discriminant of 0. And so that discriminant of 0 tells us that we have only one root for this. And so once again, we can come back and check this in GeoGebra by graphing y is equal to 4x squared plus 12x plus 9. And so if we come back over to GeoGebra, so let's get a new graph for that. And we can put in our equation. Again, this time we're putting in y is equal to 4x squared, and for the x squared we're putting in the caret again, so x squared plus 12x plus 9. We hit enter, and sure enough, looks like our parabola is just, if we kind of zoom in a little bit from that, we can see that our parabola sure enough is only touching the x-axis in one particular spot. So right there we have one real root, exactly as our discriminant was telling us. We would have only one real root. And so kind of a last example, we can come over and compute the discriminant for a an equation, negative x squared plus 2x minus 5 is going to be equal to 0. So one more time, we need to identify exactly what our coefficients are. So a, b, and c. Well, a is multiplying x squared, so a is going to be negative 1. B is multiplying x, so b is going to be 2, and c is going to be negative 5. Remember, anytime that we've got a subtraction, or that's really telling us that our coefficient, our number, is going to be negative. So we've got a being negative 1, b being 2, and c being negative 5. Well, if we plug that again into our expression for the discriminant, so the discriminant d is going to be b squared minus 4ac. So we've got b as being 2, so 2 squared minus 4 times a is negative 1, and c is negative 5. So 2 times 2 is going to give us 4, and 4 times negative 1 times negative 5 is going to give us 20. So we've got 4 minus 20, which gives us a negative 16 for the discriminant. And since the discriminant is negative, we should have no real roots for that. And so just like the two previous cases, we can take those and we can check this by graphing y as equal to negative x squared plus 2x minus 5 in GeoGebra. So if we come over to GeoGebra one more time, then we can get a new graph. And so we want to put in our equation y is equal to negative x squared plus 2x minus 5, and hit enter. And sure enough, what happens in this case, now we see that we've got a parabola that's opening down. And sure enough, that parabola is opening down. It's all below the x-axis, and so we have no real solutions. We never cross the x-axis anywhere in the xy plane that we're able to see. And so sure enough, the discriminant, one more time, does tell us the correct number of solutions. We get no real solutions in this case. And so the discriminant in and of itself is a pretty powerful little computation that we can do, and just that gives us a lot of information about the graphs of these quadratics. So this has been kind of our first step into the quadratic equation, and so stay tuned for more information coming up.